All right, we're going to start off our Unit 3 talking about exponents, radicals, and scientific notation. All of these things are interrelated. Just like addition and subtraction are inverses of each other and they undo each other, or multiplication and division undo each other, exponents and radicals undo each other. And then scientific notation is just using rules for exponents, which we'll talk about later. But first, before we do that, open up your packet to the back side, and there's quite a bit of room at the bottom. We're going to take some quick notes just using some vocabulary that we need to know about. So underneath here, I wrote down some notes, and you can go ahead and start copying them while I talk about them. So you can do that on another piece of paper, but here's a nice, easy page for you. So in math, we kind of break up our numbers, the numbers that we work with, into major groups. And you have probably heard these expressions already, but you might have forgotten them. The majority of our numbers are going to fall into the real number category. Real numbers break up into all sorts of subgroups, but basically non-real numbers are called imaginary numbers. And they're basically when we take the square root of a negative, and we know that we can't take the square root of a negative because you can't find a number times a number itself equaling a negative. So any square root of a negative is going to fall into that imaginary number category. An example would be 2i. I was that symbol we use for imaginary numbers, and that's a very small group of numbers. We don't use those a whole lot. The majority of them are going to fall into real numbers. Real numbers break up into two big groups called rationals, or rational numbers, and irrational numbers. Let's deal with irrational numbers first. Irrational numbers cannot be written as a fraction. There is no way to write an irrational number as a fraction, meaning you have an integer divided by an integer. So some examples of irrational numbers would be a lot of our square roots, or cube roots, or whatever. So the square root of 2, if you find that number, we can't write that as a fraction. Square root of 31, and pi is also a super common irrational number. Over here in rational numbers, well, rational numbers can be written as a fraction, as a over b, where a and b are both integers. And rational numbers can be broken up into some pretty major groups. Because we can write that rational numbers as a fraction, we can also rewrite those fractions as decimals. And those will break up into two groups here. We have repeating decimals, which means that the decimal repeats in a pattern forever and ever and ever. Notice we have to have it in a pattern. Irrational numbers up here, if we write these as a decimal, that decimal will also go on forever and ever and ever, but there will be no pattern. The numbers will just repeat in some sort of random order. Here, the numbers will repeat in a pattern. So for example, 5/3 is 1.666666666 repeating, and we use that little line to say that it's repeating. 22 over 7 is a great approximation for pi, and we get 3.142857, and then the 142857 repeats over and over and over and over again for infinity. So we have repeating decimals. Then the other group is terminating decimals. Terminating means to end, to stop. And so here are the group of decimals where your decimal ends. It might either end right away, it might end after a while. Maybe you don't even get a decimal, maybe you end with a whole number. That's still part of the terminating decimals group. So an example would be 5/2, which is 2.5, stops. 15/3 is 5. And then a subgroup of terminating decimals, which we use a lot, especially in elementary school, is integers. And that consists of your positive and negative whole numbers plus 0. And examples would be -7, 42, and 0, tons of other integers. And then even in integers, we can break the integer group down even more into like counting numbers, which would be just the positive numbers, not the negative numbers. Those are really the numbers that you use in elementary school. But these are the kind of the basic general terminology that you need to know. So write that down in this area. And then you're going to use this terminology to practice some basic terminology on Pizzazz page 203.